So the first thing I just wanted to help everybody understand, when you log into your GitLab and you're setting up for work with the other members of your group, you come in and you create a project and you've given it the name for the assignment. And one of the first things you see when you create your repository for your project is maybe some instructions for how you might make a clone and then have another copy of your project on your own computer. So then you can do your work. When you're done, you do your add, your commit. So on your local copy, you have your own files, and then you do a push command to then contribute those files into the remote project on GitLab. You want your other members of your group to be able to do this as well. So when you go to settings for your project, you can select the members and you can add more members. What I would ask you to do, please, is do not add me as a member of your group. I'm not going to be debugging anything for you. That's your own job to do that for your writing the code for your assignment. So please do not add me. Once you add your members, make sure you're selecting them to be a developer. Now that will allow them to contribute to the project. They can grab a copy of it. They do a clone command like we showed in the video before. But the other thing you're going to need to do is click on protected branches. And because this is a completely new project with no files in it yet, when I click on that, it just takes me back to the same instruction page to get started. So I've got the other one here for our notes. And I'm going to go to that project in a second once it loads. And we've got Comp 340 for the winter 2022 semester. And some of you have already contributed your quiz file, which is great. So when you get set up with your own project and you've contributed a file to it, you've got your main branch set up, you can click on your settings and then go to protected branches. And in that option, you can go to the master branch and you can select the option so that developers can push. Now that will mean that anybody else that you're working with on your project, they can add files to it when they do a push, or they can even delete files. So I just want to remind you as well that as soon as you've got this set up, make sure that you've got your own second copy of your work. You have a separate file with your own files to get more comfortable with collaborating using Git. Because this is, for the first assignment, it's just experimental. It's giving you the practice so that when you share the files with each other and you slowly make progress together, you can edit each other's files. That's okay, because I can see what each of you has changed in the file. But that makes it a little bit more complicated because maybe there's conflicting changes that the two of you might have made on the same project. And that takes a little bit more work to get familiar with that. So what I would recommend for right now, just getting more comfortable, work on your own files. You can collaborate together on your shared project on GitLab. And when you allow the other developers to push, there could be the same named files. What I would say is try to make sure everybody is working with a file that has a different name for now. And then you don't have to worry about maybe the two of you making some kind of change on the same file, which we want to get you to that point. We would like you to be able to work together on the same files. But we're going to have to know how to deal with conflicts in order to get there. So first, right now, you just want to make your own files, push it to the repo, give everybody else a chance to do that too, and make sure to select that option and click on it to make the change. Let's see if I click on this, developers can push. And then when I press the button, it's going to ask me, do you really want to do that or something like that? and you're going to want to say yes because you want to collaborate with everybody. So you can set up your projects so that if there's somebody that's the manager of the project, they get to decide what changes people can make to files, and you could organize a project in a different way. But to get everybody comfortable, I like to make it so that everyone gets a chance. You can push, you can all make changes to the project. We want to give you a taste of how Git will work. Okay, so it's not mandatory for you to work collaboratively for the first assignment, and you're submitting individual files with your own bundle from your own local copy of the repository. If you've got a clone, you submit your bundle from that, your own local clone. The instructions for the first assignment have it so that if you are looking at the instructions the day before or the day that it's due and you haven't done anything yet, then you're going to come in when you see your group's files and you look at the project, then you're not going to be doing the same kind of code. Instead, you'd be looking at the code that's already there and you would write test code instead. So if you're coming to the project that late, you really have to start thinking about how you're going to do your own work that way, because you're clearly not listening to anybody else or collaborating with anybody else. So then you're going to figure it out on your own. If you still want to talk to me about anything, you're very welcome to email me with any kind of questions. You get your group set up on your GitLab and collaborate together, that would be great. You slowly work on it a little bit at a time every day or every other day. And you're just doing maybe half an hour or an hour, you break it up like that, you're going to make very nice progress just walking slowly. So that way you have a good experience rather than trying to cram and submit everything all at once or try to do your work all in one day, which means you're probably not going to remember very much of what we're doing if you're trying to do your work that way. Something else you need for the assignment is we've got a volunteer for the class. I'll post an email for her. You can get in contact if you're looking for somebody else to talk to in the class and you don't want to talk to me directly. We want to have that set up for you as another option. And I appreciate very much having Navneet volunteer for that. We could have a couple more volunteers if you're interested. Please email me, we can get you set up. I don't have to have a really long conversation with you to just go over 20 minutes, just explain what you could do for volunteering. And then if you really like the idea of doing this, I really appreciate that help. And I would love to, at the end of the semester, get you set up with a letter for reference when you're applying for jobs. Here we've got our main program. If you want to read in the arguments from the command line. So I want to make sure I've demonstrated this if I haven't done it in a video already. So you could do touch and do main.c to get started with an empty file, but I've already got a small one right here. So we'll do nano main.c, and we've got the two included libraries at the top that you're familiar with now. And the only real difference here is that the main function has two parameters. The first one is called int, and then it's got the specific name argc. This gives you the number of arguments that were typed on the command line when we execute the program. That's separated by white space. The second parameter is we've got argv, and then you'll notice the combination of the elements will be pointer type, and then we have an array of those element types. So what this really is actually an array of strings, and each element represents one of the arguments that was typed on the command line. And then when we iterate through those and we can print them, we've got a loop, and we're just going to print the integer value for each argument. So we're going to number them from 0. And then we can print out what that argument is with %s. So our printf, I know when I tried to do this with navneat, this is the problem we had navneat, I forgot the I. And then we had the segmentation fault. And then argv, you get access to the element you want to print for to match with a second format specifier. And then that's it. We exit from the program with exit success or the value 0. So you've got that. You can compile gcc main.c-o main. So I just like to call the name of the program the same as my source code file, the main one right now. Sometimes I like to call it app. And then once you've got that, we have main, and then you've got your arguments that you can see are displayed. It will iterate through them. The one thing you'll notice is that the very first argument is actually the name of the program itself, and that gets counted as the 0th argument or element with index 0. Okay, that's enough to just get you to the point where you can start working with the command line arguments. And you could type whatever. It includes underscores, dashes. And you can see the only thing that's separating it would be white space. And there you go. If I gave more space between those or a tab, even I think if it doesn't even display on the command line, you can see it still reads it in and breaking them apart by white space. Now, when you're reading them in like this, if we take one more look at the program, you'll notice that I have not allocated dynamically any of the memory for these arguments. And so this is automatically set up when you use command line arguments this way. But for the assignment, you need to go through and you got to take each of those elements and be able to dynamically allocate the correct number of characters for each argument, which each of those arguments then, if it has many number of characters, each of them would be an array of char. So you have to figure out how to dynamically allocate enough space for the characters and then the null character at the end, \0. And that indicates the end of the array of characters is \0. So you have to allocate enough for the number of characters +1 for the \0, the null character. Now that's what makes it so that the other functions you're going to use when we look at the documentation, this would be for stdio.h for that header file from the documentation. And there's all kinds of other functions. This is typically input output. So this would be reading from files mostly. And it's not going to be the functions that you're using to help you process arrays of chars. So let's take a look at some of the other headers that are there. We've also got stdlib.h. And you'll notice that it also has some functions for string conversions. But then there's another library, string.h, and we've got string handling. So this one is very useful for managing everything we got to do with strings of characters or arrays of characters. You'll notice the names of some of these in the descriptions. We've got some of them that do conversions for you from characters to numbers or different data types. Maybe you want to copy, and there's a couple different kinds. But part of the expectations in this course is that you go to the documentation and you got to read and figure out how to use some of these functions. String and copy, and then it describes each of the parameters. It gives them the names. You might not always know exactly what the names, what they mean, just looking concisely at the top. But you look at the corresponding number, and that's the different ways that you can use this kind of function. It might be overloaded. And then you go to the specific description you're interested in, and that describes the way you're going to use that one. And they typically have a little bit more of what each of these parameters are going to do. So that way you don't have to rewrite a bunch of code yourself. Now I might have put on the instructions as well that you're not just going to use some of the library to do things for you. So in that case, you could look at the documentation, get a good idea of what that function does, and that could help you write code where you might be able to go through and you're going to write a little bit of how it's going to work yourself with a similar kind of function. So with something like copying, if I know I'm trying to copy an array, I'm going to have to do it element by element rather than just relying on a function like this. You can see some demonstration. Oh, they've got the null character within the array, even though it has 6 bytes. And it says hi, and you can see more \0, null character, null character, null character. And then there might be some more values after that. If you go to try to do anything with a string with a lot of these other functions, it's only going to work with the very first 2 characters, hi for hi. And then it knows to stop because of the null character after that. So a lot of these functions you see in the library, they stop at the null character. Okay, and then there's some additional stuff that if you're looking at something and it's not quite what you need, then typically down at the bottom, I might be like, okay, I need to remind myself of maybe something that's similar. And I can't quite remember exactly what it is, but you'll get those recommendations down at the bottom, and it might be what you're looking for, because I know navigating the documentation can be a little bit difficult at first. You want to do a little bit of reading to help yourself get more familiar with what's there in the C libraries. You don't want to try to memorize everything, so you just got to break it down and just do a little bit at a time. So that's why we've got, the focus for this assignment to get you started with getting that practice, and then also just getting a little bit of reading that's going to help you in the future when you got to program something more difficult. So get more comfortable with the docs. Okay, hopefully everyone's doing well in your groups and that you're talking with each other. You're breaking it down, doing a little bit at a time. You get that practice now, it'll help you so much later.